The paravane is a towed-winged underwater object, a water kite. Paravanes have been used in sport, commercial fishing, marine exploration and industry, sports and military. The wings of paravanes are sometimes in a fixed position, else positioned remotely by actions of a human pilot. Pioneer parafoil developer Domina Jalbert considered water kites hardly different from air kites. However, paravanes generally orient themselves in respect to the water surface. They may have sensors that record or transmit data or be used entirely for generating a holding force like a sea anchor does. While a sea anchor allows a vessel to drift more slowly downwind, the paravane travels sideways at several times the downwind speed. Paravanes are, like air kites, often symmetrical in one axis and travel in two directions, the change being affected by jibbing, shunting, or flipping over. Military applications. The paravane weapon was developed by the British inventor Sir Dennis Burney as a means to sweep enemy mines. Towed behind a ship, the paravane wire would either cut the mine's mooring cable or bring the mine and paravane together, detonating the mine. There are offensive and defensive paravanes. There are main paravanes and auxiliary protector paravanes. Some paravanes are equipped with cable cutters that cut the moored mines. Explosive paravanes are essentially a towable or controllable mine. The U.S. Department of Defense continues to have interest in paravanes. Abstract. A paravane includes an elongated fuselage, a wing section of spaced wing members attached to an intermediate portion of the fuselage, stabilizer, fins for maintaining the paravane lined up with the direction of tow, a depth control flap positioned adjacent the wing section and having a pivot axis extending closely adjacent to the towing point, and depth control means of controlling the position of the control flap. The wing members have a straight leading edge portion, a straight trailing edge portion and a curved intermediate portion wherein the wing members are arranged such that the chord lines extend at oblique angles with the longitudinal axis of the fuselage and such that the resultant hydrodynamic lift force vector acting on the wing section passes through the tow point. Department of Navy, Washington, D.C., 7 August 1984. In commercial fishing, there are arrowhead paravanes, flexi-wing paravanes, and bi-wing paravanes. These water kites are used in tuna fishing operations. Trolling for fish devices that are paravanes or water kites do not always use the descriptor. George Dahl in 1957 taught how to kite his device underwater in order to place bait at the desired depth, and he wanted to have a boat have several of the devices being towed at the same time, without the devices and bait interfering with each other, so his device was able to be set for different deflections. That is, the various water kites would be set to fly in the water at specified positions. Trolling device. In marine industry, water kites help depress cables being placed as well as other payloads. The deep dive wing one bridles at different points of the wing for payloads that are larger in cross-section because of the increased parasitic drag of the payload. The DDW uses less cable than a non-kitted payload to reach lower depths. DDW-1 is without a magnetic signature. Deep dive wing one kites instruments underwater. Paravanes are also used in the marine seismic industry to drag streamer cables on a large width behind the seismic vessel. In sport fishing. In 1905, Martin Flegel of Minneapolis, County of Hennepin, and State of Minnesota, invented a lighter-than-water water kite that could be operated from boats or from the shoreline for the purpose of trolling for fish. The paravane, or water kite, would float on the surface of the water, but the vanning was in the water. The device would move oblique to the towing effort. His device's operation had a way to fully change directions. Paravanes carry bait to specific depths. Some fishing lures of themselves paravanes. Deep diver. In sports and play, towed human on-board paravanes are used to transport explorers, scuba sportsmen, spear fishing people. Speed sailing has been driving the use of water kites. A group has developed an air kite that dynamically was coupled with a water kite that they also developed. French Laldo. The group succeeded in having a double kite system with one kite an air kite and the other kite a paravane water kite. The air kite dragged the submarine water kite. This examples dynamic soaring or dynamic sailing using two media, air and water, by Luke Arment. A very complete document is at large file of 36 MB. http www.orgadelair Jumla Bressets Luke_Arment Aldo PDF. Early work in coupling water kites was done by the late J.C. Hagedorn, a geophysics professor at Delft University. His system coupled manned parafoils with water kites he named HAPIS. Later experimenters also used the terminology gendarme or sea dog, although the attempts to implement the manned versions were probably never successful. Many experimenters have demonstrated smaller unmanned versions constituting a fundamentally simple sailing system, a kite in the air connected to a kite in the water. There is a race to break speed sailing 50-knot barrier. A major project is exploring a paravane to result in a non-heeling moment wing mast. Swedish Speed Sailing Challenge holds people affecting such paravane use. Swedish Speed Challenge paravane sailing. Similar technology is found in Yellow Pages endeavor. Such speed record efforts are related to the Windjet project. The Jellyfish Foiler is a water kite hydrofoil tugged by an air kite reaching for breaking speed sailing records. A state-of-the-art hydroptero powered by kite. The kite on the Jellyfish Foiler gives tension through a rigidized tether pulling on the water kite hydrofoil hydrodynamic center in order to avoid roll. Jellyfish Foiler technology. The Jellyfish Foiler lower hydrofoil has two J-shaped foils and one center T-foil rudder and is pulled by the upper air kite. The system is a closely coupled double kite system resulting in a system that will fly through the air and water in an effort to break the 50-knot speed sailing record. In science. Paravanes are used for sampling water chemistry. Controlled kiting to specific depths allow scientists to map water qualities in the oceans and lakes of the world. A towed instrument vehicle for deep ocean sampling. An array of pontoon paravanes wings are set so each water kite positions itself so it does not interfere with the others. One use has been the holding of seismic instruments. Patents. Apparatus for offense and defense against submerged or partially submerged obstructions. U.S. Pat. 1,358,358 filed September 18, 1917. Bernese patent on the paravane idea. U.S. Pat. 2,556,423 water kite. Herbert L. Gross filed April 26, 1949. Water kite. Filing date April 27, 1951. Water kite and method of using the same. Kenneth D. Anderson. Tripanel hydrodynamic depressor for fishing. Filing date March 12, 1993. Trolling device George H. M. Dahl. Filing date October 3, 1957. U.S. Pat. 3,703,876 underwater towed apparatus. Inventor Finn C. Mitchelson. Filed in 1970. Underwater fishing kite Clisolda L. Luthen. Water kite, 1881 U.S. patent 242,278. Described use of a water kite. Bathymeter, U.S. patent 4,719,987. Biplanar pontoon Paravane seismic source system by Robert K. George, Jr., Lawton E. Trent, and Ernest R. Harrison, filed March 23, 1987.